Hey guys, today we are comparing triangles to determine if they are equal or congruent, which remember is our fancy word that means equal. And the symbol for congruent is equal with a little squiggle on top. You'll know you've got it when you can write a congruent statement for SSS and SAS. So these are two theorems we're about to learn about. So what are congruent triangles? Well, congruent means equal. So congruent triangles are two or more triangles that, since they are equal, they have three equal sides and three equal angles. So if we look at this example here, we see one dash mark on these sides, two on these sides, and three on these sides. So that shows us that there's a set of equal sides for all of the sides between the triangles. So these are an example of congruent triangles. The way we prove triangles are congruent are by four different theorems. So those are going to be called SSS, SAS, ASA, and AAS. And with these names, an S means side, and an A means angle. So by looking at a pair of triangles, if we know just three pieces of information, and it's any of these specific orders of information, then we automatically know that the entire triangles are congruent. So over here, we were given three sides. So this is actually going to be an example of SSS. And since this picture shows us the sides are all equal, we also know that all of these angles are going to be equal and that these are the exact same triangle. They are congruent. So we're going to talk more about SSS and SAS today. So if you slide your paper down, I just said that side, side, side is when you have three sets of equal sides. So looking at that same picture, let's go ahead and write out those equal sides. So here I have AN is equal to side LC. Then I have the two dash side. So side PN is equal to CK. And then last but not least, we have the three dash marks. So that shows us that PA is equal to LK. And now that we see all these sides, I'm going to write what is called a congruence statement. So I need to name this triangle and say that it's congruent to this triangle. But because of the order of sides, we have to name them in a certain order. So if I name this one ANP, I say that is congruent to this triangle. If I started at A, I went along the side that had one dash mark. And then I went up to P along the side with two dash marks. So I need to go in the same order over here. I need to go along the side with one dash mark and then down the side with two dash marks. So that order would be L, C, K. Now I know that those two triangles are congruent. Alright, let's take a look at one of the other theorems. So over here we have side, angle, side. So this is when you have two sets of equal sides and one set of equal angles. Something super important about the angles part is that the angles must be in the middle of the sides. So if we take a look at our picture over here, I see that this angle is given to me as they're both 90 degrees. So I see that angle C is equal to angle F. And then sure enough, these dash marks on the sides show me that the side angle side goes in the order side angle side, which is exactly what I need. So I see that these sides with one dash mark are equal, so CB is equal to EF. And then with two dash marks, those are equal, so AC is equal to FD. And if we just want to check that it's side angle side, a really good thing to practice is to label what you've got. So I see that this right here, the congruent markings, is showing me a side. This congruent marking is showing me an angle. And this congruent marking is a side. So if I label using S's and A's, and then I read around my triangle, I see SAS. So that's how I know that it's this theorem. Now the last thing I need to do is name these triangles. So if I name the first one BCA, going along the 1 dash side, up the 2 dash side, BCA, that is congruent to, I need to start and go along the 1 dash side and then down the 2 dash side, so EFD. Alright, so those are 2 of our 4 congruence theorems. We are going to do more about these in class, and then we're going to do the other 2 for next time. But before we wrap up this video, I need you to flip your notes over. I just want to show you one quick thing about congruent triangles. Sometimes you're going to see them on the coordinate plane, and it looks a lot more intimidating than it actually is. So if we ask if these triangles are congruent, well, one really easy thing I can do on the plane is just count how long the sides are. So if I look at this side right here, it's a nice straight line following the grid, so I can count 1, 2, 3, 4, 5. That is 5 units long. If I look over here, kind of looks like this side might be the same, so let's check. 1, 2, 3, 4, 5. It is the same. So I'm going to go ahead and point out that AB is equal to ED. Let's check out another side now. Up here is 1, 2, 3, 4. 1, 2, 3, 4. Well, don't you look at that. We got AC is equal to FD. And if we look at this, we can't quite count that one, but you guys did learn something called the Pythagorean theorem. So we can figure out that side. So if we have 4 squared plus 5 squared equals C squared, and we solve that out, we end up with the square root of 41 is C. So I'm just going to write it as the square root. And since both of these have the sides of 4 and 5, this side is going to be the same as this side. So that shows me that side BC is equal to side EF. So I see that I have 1, 2, 3 sets of congruent sides. So then that means these triangles are congruent by side, side, side. Yes, these are congruent. Oh, you can't see that. Yes, these are congruent by side, side, side. Side, side, side. So if I want to name those triangles, I'm going to call this one A, B, C. So it doesn't matter the order you pick for the first one, but I need to follow the same order. So A, B, C, I went down the 5 and up the diagonal. So I need to go across the 5 and up the diagonal. So triangle D, E, F. Or if you look at it, what kind of triangles are these? Hope you said right triangles, because we've got a nice 90-degree angle there. I see that angle A is equal to angle D. And since those angles are equal, and we've got a side on each side that are equal, then SAS is also a good congruence theorem for this one. But this points out exactly what congruent means. If these triangles are proved congruent, whether it's by SSS, SAS, or one of the other 2 we haven't learned yet, you just need one of them to work, and all of them automatically work. because these triangles are congruent, so all parts are equal. Alright, thanks for watching, guys. I will see you in class.